Well, hi, thanks for joining me here in my shop. I'm going to be testing all the tubes in this radio at this point, just to be sure that they're working well. I'm going to be using the Weston 981 tester, and we're going to start out with, let's see, which tube should we start with? Why don't we do them in order? Let's start with the front end tube here. First tube is a 6SK7. Okay, so we'll dial up. Now, some of you really enjoy watching tube testing, and that's why I'm going to put this all on video. 6SK, but of course you can always skip forward and see the results as they come out if you want. 6SK7, there it is. 6SK7, 6.3, signal level 2, bias is 25L, selector buttons 17251, 17251, 4630, 4630, 44 on the meter sensitivity, C for the plate setting, 1520 is what we're looking for in the meter, so right up around mid-scale here. There we go. Now, if by some chance this is the first time you're watching tube testing being done, one of the very first things you want to do is find out if there's a bad short circuit in the tube, because a shorted tube can be a risk to the tube tester. So that's what this first test is. We're going to do it. We watch the meter and hope it doesn't go up. That's good. So this is measuring leakage current between elements in the tube. They don't have to be shorted, hard shorted. They can just be lightly shorted, I guess would be the word. And this meter will show it. Okay, let's just check the line voltage here before we. It's just a touch high. Here we go. Higher than the middle. So our first test shows this tube to be good at 1750. 1750. Now there's another 6K7 in this radio. I'm going to grab right now. Try to grab it here. 6K7. Which one is it? Might be the IF amplifier. 6SK7. Okay, great. So the machine's all set for this guy. Right, 6SK7. In you go. Watch the pilot light now. And you see it dip slightly? That's proof that the heater is drawing current in the tube. And I don't know if you could see that on the video, but I can certainly see it with my eye. Okay, we'll check for short circuits inside the tube. Generally, if a tube had a bad short circuit in it, we'd know it already because we played this radio and it worked. We can't expect these to be too bad. Here we go. Just like the other one. Very good tube, according to this test. So that's the front RF and the IF amplifier. This will be the mixer tube here, probably SQ7. SA7, 6SA7. I'm going to reset the machine now for a 6SA7. Single test, 6.3 volts, signal level 2, bias 9L, 27345, 27345, 1650, 1650. Sensitivity 46. C Okay, so 720, it says whole tube, so this is a multi-part tube, but in this case it's going to test it all at once in this tester. Okay, in you go. So what this tube does is it's mixing the local oscillator with the incoming antenna signal to derive a difference signal, and if that different signal is 455 kilohertz, boom, right through the radio and out the speaker. That's what this guy does. Okay, now 750, isn't that what 720? 720 is yeah, right about there. Whoa! Holy smokes, that doesn't seem right. How does that happen? Get that high. Let's just double check here and make sure I haven't made a mistake. 6.32, 9L, 27345, 27345. See, I didn't double check these because I know you're watching, and if I made a mistake you'd tell me. 1650, 45 on the sensitivity. Oh, I see what I read wrong. It's not 720. It's 1100. Okay, so, well, that's not much different. It's only up to here. Wow. Well, I can only qualify as good for this test. That's 3 of them. Now, okay, next tube. I'm just looking it out here. SQ7. So this is the detector tube. Again, it's a multi-part tube. 6SQ or more. It's more tubes than one. Now this does 2 tests. Okay, so actually it does 3 tests in fact. So 6.3 signal level 1, 18L. 25100, 25100, 3760, 3760, 6SQ7, 25100, 25100. Yep. Sensitivity 37. Plate is on F. First test is the triode part of the tube. It's the audio triode, and it should come up to 760, up around here again. Okay, let's just check the line check again, just to see where we are. Right on the money. There's a little red arrow here for line check. I have a hard time seeing in the camera. Okay, any shorts on this guy? And GM 720. So it's that's coming out at 800. So that's good. Now the second test on this tube, testing the diodes. Change the switch settings. 2013P. 2013P. Now I pulled the tube out just because I'm a little nervous. 0760. 0760. There's some testers you can change these all your life as long as you don't push the test button. But in other ones, as you change these, you are actually putting voltages on and off the tube. You can dial in shorts and all kinds of stuff. So you gotta turn the unit off or pull the tube out to change these settings. And I just get a little nervous because I have 4 or 5 tube testers and I can never remember which one is most sensitive to this kind of stuff. Don't want to get that wrong. Now let's double check. 2013P. 2013P. And 0760. 0760. We are ready to blast off. P1, P2, diode check. Okay, so I'll just do this short thing just in case. Hey, wait a minute, we have no tube in. Not going to get much of a result like that. Just give it a moment. Now, shorts in a tube, you know, they can be momentary contacts. They can be not there when the tube is cold, and especially leakages. When the tube warms up, it becomes leaky. I'm testing it pretty cold here. But again, we don't really have any reason to suspect any of these tubes to begin with. So a diode check, we push this switch, and this has to come up above the diode mark right here. Diode, test good, and then there's another second one to test right there. Line check, here we go. And of course it tests good too. Put that back. Okay, so all tubes are checking out here. And again, not any surprise. This radio is exhibiting low volume. Maybe we're going to find out why pretty soon. Now what is this tube doing here? 6SF5. Okay, so this is something. This is a different tube from. Yeah, what is this? I haven't seen one of these before. 6SF5, and it looks like it's a preamp. Or you know what it could be? It could be an inverter tube because there's a push-pull output. I'm pretty sure in this radio it's push-pull output. There's two output tubes. And so you would need some way to invert it. You know, do it with a transformer, do it with a tube. 6SF5. Maybe, so 6SF5, there it is. Signal 2, 18L, that's interesting. 21503. 21503. 0760. 0760. Same as that. 6.3 volts, of course. In you go. Take it out right away. I didn't go far enough. F. What am I doing? What happened to me there? I killed the patient. Did not follow the procedure, and the patient has died. 6SF. No, he hasn't died. Patient only dies if I push the button. And the patient that might die, it might be the tube tester. I make a bad boo-boo here. Let's double check because I'm all over the map. 21503 0760 with an F, 6SF5. Okay, shorts. None of those. Here we go. What's it supposed to be? This is supposed to come up to 970, so just about 1,000 here, right about there. Right on 970. It's right on. So this is called the reject point on this tester. If a tube tests below the number that's written here, it's time to scrap it. So what we'll do is we'll do a little sensitivity study here. I'll vary a few of these adjustable controls here. Just watch how far the meter moves. If it moves a lot, it's pretty much, this is pretty much at its max point here. So it's not going to do anything except reduce it. Okay, and this one, grid bias. So it varies quite a bit. Let me just make sure I got these exactly corrected. 18L. So this should be right on 18. It's right on 18. 46. So this is a little high now. I'll put that there. I don't think it'll make any difference. 970. It's actually coming out at 9 at this point. So this tube is actually failing this test. So the tube is operating. The radio works. I think this might be the cause of the low volume. If its job in the radio is just to invert the signal, maybe not. We don't know exactly what this guy's job is. Not at the moment. Okay, let's stick them back in. Now I have the two output tubes kind of tucked in here. Again, I don't want to work them by the glass. Pretty much scared it out of there with that big screwdriver. 6K6, made in Canada. That's a fairly small tube. 6K6. Okay, 6. So there's a series of output tubes, have similar numbers, 6K6, 6V6, 6L6. Ooh, 6L6 is quite different from the rest. But all the rest are fairly similar in various respects. 6.3 volts, signal level 2, 46H on the bias. So I imagine the H and the L are high and low. 46 high. 07345 0 7 3 4 5 0610 0610 44 on the sensitivity. F. Okay. And it just has 1360. So I want to get 1360 out of this guy. For sure it's 6.3 yet. Okay. Saw a little flash there. Again, like if this tube were defective, I don't think the radio would have worked. But you know, low volume. Defective or worn out. There's two different things. It may not be defective, but it may be worn out. Okay, let's give it a check here. Good there. And this tube, 6K6, should test, 1360. So a little bit below the halfway mark. It's really close. So that's 11, 12, 13. Wow, that's almost exactly 1360. So this is another reason, possibly, that the radio's a little quiet. Let's test the other one here. See if I can scare it out of the socket with this big screwdriver again. Yeah, not fighting back. Oh, it's this microphone over here. Something a little loose on this one. Doesn't seem to be inside the glass globe. It's probably getting trapped in here. No consequence. This is a 6K6, is it? 6K6, alright. In you go. So the dip. Now there's also a rectifier tube in here. I guess I may as well test it too. Let that warm up. Now get that tube out. Okay, shorts on this one. Nope. F. Yep. GM 1360. Here we go again. Oh, so this one's testing low now. 1200 instead of 1360. So based on this tester, these two tubes would qualify as being time to replace, and the effect probably from them is low output, which is one of the traits of this radio. So this is a 5Y4, yep, 5Y4 rectifier tube. So let's flip this onto 5 right away. So don't get that wrong. 5 Y. 5Y4 is right there. Zero zero 003 P 0030 P 0760 0760. $25 on the sensitivity. E. So as a warning here, F, it will show a short on one pin. Probably setting number 1 on the short test will show a short. And then we do 5Y4, P1 and P2 for 2 tests. There's 2 plates. This is 2 tubes in one. So full wave rectifier. 5 volts, we're good to go. Saw the dip. Now a big tube like this often can draw a fair bit of current. So we want to check the line check here just to see if it's dropped. And it's dropped a bit, so we're going to compensate. Bring it up. Checking for shorts. Remember, one of these will probably show a short. There it is. It's not a problem. So rectifiers and diodes. This is the test switch. Rectifiers up here. That tests good. The other plate, very same. Nothing wrong with this tube. Out you come. And turn down the line adjust there. So there we are. So what do we know? We know this radio appears to be weak. We don't know why. It can be weak in any place along the chain, and the volume would be low on it. The 2 output tubes are probably the cause of the low output. Can't be sure though. Can't be sure of anything. We'd have to put 2 better 6K6s in there to find out if that's really the case. The rest of the tubes testing pretty good. Apparently they don't plug back into their sockets though. I'm not getting this. So, okay, I'll do that. So that's the tube test. So I think we just carry on working on the radio. Bear in mind that maybe the audio can't be lifted up in any other way except to put better output tubes in. 6F6, I probably got a few of those. I'll have to check around through my output tubes and see what we've got. Those are nice. I like those 2 identical glass tubes. They look nice in there. But that's it. That's it for now. I'll see you on the next video. Thanks for watching.